Okay, this is in your textbook on 5.4, page 218. You can follow along, and also in your notes, please open it up to the page that says solving a system of equations graphically. A system of equations is two or more equations graphed together on the same graph. For example, here is a system. Y minus x equals 3 and x plus y equals 1. We've been solving these algebraically and then checking them. So now we're going to use the graphing calculator and put these standard form equations into y equals mx plus b form, graph them, see where the two equations intersect, and call that the solution. So we're not going to be doing elimination, substitution, or chart method. The algebra way of solving this, we're going to be doing the graphing way of solving this. So first example here. You can see that this one's already all done for you on the first page of this notes. Look at the graph below. You can see that where those two lines intersect, that's their solution. So how do we get those two lines to intersect? First thing you have to do is to solve them for y equals. You have to put them into the function form, or what's called y equals mx plus b form, the slope-intercept form. So you can see that the first equation is y equals x plus 3. The slope is 1. The y-intercept is 3. That's the equation right here, the positively sloped line with the y-intercept of 3 there. And then the second equation, solve for y equals negative x minus 1, having a negative slope and a y-intercept of negative 1. That's the second equation. And these two equations intersect at the point negative 2, 1. To be sure that that's the solution, you have to check to be sure that this goes into both equations. There we go. Okay, so the solution to this system is where the lines intersect. Checking the point negative 2, 1 in both equations. And you can see that, yes, the check does work. Just the same thing that we did with elimination and substitution. So let's go to example 1. If the smartboard was working. They keep skipping to random pages. Weird. Never had this happen before. Here we go. 2x plus y equals 7 and y minus 3x equals negative 3. Graph the lines using a table of values or point slope. I'm going to use point slope. So this equation is y equals negative 2x plus 7. The slope is negative 2. The y-intercept is 7. Second equation, solving it for y equals, putting it in point slope or slope-intercept form, is y equals 3x minus 3. The slope is 3x, there's 3, and the y-intercept is negative 3. So, using those as my guides going to the graph paper, my intercept of 7 and my slope of negative 2 down 2 and over 1, down 2 and over 1, remember rise over run. So when I put on at least 3 points, minimum of 3 points for the checking purposes, and yes, we want to make sure that our lines are long and extended beyond the 3 points of our equation that we've solved for. That's the first equation. The second equation with a y-intercept of negative 3, so starting down at negative 3, and a slope of 3 means going up 3 and to the right one, up 3 and to the right one. We can see where these two lines are going to intersect at x equals 2 and y equals 3. So use your ruler, extend your lines, making sure that they are nice and straight. And yes, I'm freehand drawing mine because my line tool is not working, but that's okay. And so we have both of our lines graphed on the graph paper, and make sure that you put it back into its original form is how you label it. So this is the line 2x plus y equals 7, not the slope-intercept form that you've written out, the original given equation. So y minus 3x equals negative 3. And yes, they do have a common solution of 2, 3. Well, we've got to make sure that that works in both of the equations. There we go. So the intersection point is 2, 3, I believe. So I'm going to check it into both given original equations, and I believe this might be wrong on your paper, so make sure it says 2x plus y equals 7. 2 times 2, the x point, and the y point of 3. So you get 4 plus 3 is 7. 7 equals 7. And checking into the second equation, putting in the y value for the y, 3 minus 3 times the x value 2. Does that equal negative 3? And yes, you get 3 minus 6 does equal negative 3. So negative 3 equals negative 3. It does work in both equations. So there's example 1. Example 2, solve the system and check. So yes, we are still going to do the full check. 2x plus y equals 5 and x minus y equals negative 2. So solving for y, you get y equals negative 2x plus 5, slope of negative 2, y-intercept of 5, and the equation, negative y. I think I would add y to both sides here. It'd be probably easier. And you get x equals y minus 2, then adding 2 to both sides to get y by itself, so we're putting it in slope-intercept form. X plus 2 equals y, or y equals x plus 2. So my slope here is 1, my y-intercept is 2. So starting with the first equation, start at the y-intercept of 5 and a negative slope. So rise down 2 over 1. So now my point's at 1, 3, down 2 and over 1. My next point is at 2, 1. So I've got 3 points. I'm going to draw my line. And starting with the second y-intercept at 2, and my slope is positive 1, so up 1 over 1. Oh, I can see that intersection already. And yes, you should extend your line beyond the graph. I don't use the graph into it. Maybe. Maybe this one. Be careful that you're making sure that you're extending your lines and going through actual real points that are on the graphs. So 2x plus y equals 5. 2x plus y equals 5 is this top equation, the positively sloping line, and the negative sloping line, x minus y equals negative 2. Remember, you have to label the equation with the original given equation. So I believe the solution is 1, 3. The solution to this is 1, 3. So yes, you should check this. So I'm going to do the checks right here. The check up for 1, 3. So 2x plus y, and you should check using the original given equation. So 2 times 1 plus y being 3. Does 5 equal 5? Yes, that's a true statement. And the second equation, x minus y equals negative 2, putting in that point 1 minus 2, 1 minus 3, excuse me. The y value is 3 here, is what I believe. 1 minus 3, does that equal negative 2? Yes, negative 2 equals negative 2. That's a true statement. So I did check the point to make sure that it works in both equations. I'm going to leave example 3 for you to do and answering this question. What do you notice about the lines? Therefore, the solution is. So I'm going to leave example 3 for you to do. Pause the video We'll check this together in class. The equations are both set to the slope-intercept form. However, you may choose to graph either using slope-intercept or a table. So do that one on your own, and we'll check that in class. So on to the last example, example number 4. Two cars are traveling along a highway, so a real-world application of this. They're traveling along a highway in the same direction. They take t hours to travel d miles from point A on the highway. Their motions are described by the linear equations d equals 60t. So this rate, 60, is 60 miles per hour. I'm sure you recognize that the rate of 60 miles per hour is in the equation d equals rt, the rate of speed. The second car is traveling at a rate of 50 miles per hour, but they must start out 20 miles ahead of the other car. So solve the system of equations graphically, which you can see it's already done there for you. The graph is on the notes here. When will these cars meet? And I see that they are going to meet after 2 hours and a distance of 120 miles. So their solution is 2 120, 2 being the hours. After 2 hours, the cars are going to meet. So that is the answer to that, 120 miles later. But it says after what time their motions are described. When will the cars meet? At 2 hours and a distance of 120 miles. And we'll practice some more of these in class tomorrow.